Hi, good morning, everyone. We are the Perennial Foods and Forage group. My name is Maddie, and this semester my partners Allison, Lily, Michaela, and I worked with John Turner at Wild Roots Farm on our project. While the semester did not go entirely according to plan, we still learned a great amount from John about sustainable agriculture, plot design, and hard work. On John's land, there are 2 high tunnels, forest gardens full of currants, elderberries, and other perennials, some annual beds that are used mainly for growing potatoes, squash, tomatoes, onions, garlic, and cucumbers, grazing fields and livestock pens, and both managed and unmanaged forested areas. John raises heritage breed pigs, goats, and occasionally chickens, and keeps a single sheep to keep the male goat company. In the summer and fall, the goats and pigs graze in the forest and in the fields of John's land. Most of the goods produced on the farm are consumed by John and his family or gifted to the community, although some annuals are sold at a local market. Soon, John hopes to expand his operation to sell meats and value-added products like syrups and teas.
However, the main mission of the farm is to provide educational opportunities to Vermont residents concerning small-scale farming and self-sufficiency. Small, holistically managed farms have to diversify their practices and utilize land carefully to be successful. Across Vermont, the profitability of small farms is declining, allowing for an industrial agriculture takeover that will negatively affect the rural economy. Wild Roots Farm is dedicated to climate-resilient food systems and education, focusing on agroforestry practices, ecological design, and regenerating biodiversity above and below ground. John, the owner, focuses on community engagement through workshops, internships, and service learning projects. We want to support John in his efforts to educate others and create a community of resilient farmers.
Throughout the semester, we were tasked with designing a small 35-degree slope using agroecological concepts that support a multi-strata food system for forage, food, medicine, and education. Our approach was to understand the theory and practices that influence the design under the watchful guidance of our community partner, John. Our plan was to assess the landscape with the intention of planting appropriate woody perennials along contour lines to stabilize the slope and allow for goat grazing and a walking path. Here you can see an aerial image of John's property, taken by UVM's Spatial Analysis Lab last year. The area that we are in charge of managing is highlighted in yellow. Here is our overall process for the completion of our project. We started by contouring the slope manually. During site visits, we also inventoried the land in order to create an accurate site assessment and analysis. At home, we researched viable flora that could be planted on the slope and planned the designs. Finally, we drafted our final deliverables.
We visited Wild Roots Farm on multiple occasions in order to complete the slope contouring manually. Using an A-frame designed for us by John, we marked horizontal lines along the slope with flags, delineating an 8-foot change in elevation with each line. The original end goal of this was to have overhead photos taken by the UVM Spatial Analysis Lab that we could use to better inform our site analysis, base maps, and the scale of our designs. However, due to complications with consistent snow cover and then later COVID, the photographs were never able to be taken. Despite that, this exercise served to make us very familiar with the site and did not hinder our design at all. We were able to move forward with our site assessment and analysis thanks to the previously taken aerial photographs of the site that we were able to obtain from John. The site in A&A serves both as an annotated map of John's property and a base on top of which we can overlay our planting map. It details the various structures and gardens that John maintains on the land, as well as characteristics of the site, like sun angles at various times of year and wind directions on the land.
To decide what plants to put on the slope, we conducted extensive research and compiled it into a spreadsheet. First, we looked at a number of different books recommended to us by John, including Edible Forest Gardens and the Intervale Conservation Nursery's Field Guide. We gathered information to answer questions like, what are the medicinal and indigenous uses? Does it attract pollinators? Does it produce food or have the potential for value-added products? Will goats eat it? Does it already exist on the farm? What is the height and spread? What are the shade and soil preferences? Then, from this spreadsheet, we selected a final tree list of about 20 species. Before this slope was a part of Wild Roots Farm, it was used for sand mining and subsequently was backfilled with more sand. This means the soil here is extremely low in organic matter, relatively unstable, and, obviously, very sandy. For our design, we decided to divide the slope into 3 sections. Section 3 at the top is the driest and most nutrient-poor section, because as water hits the slope, it collects nutrients and carries them downhill. This is why section 1 at the bottom is the most moist and nutrient dense, and thus the best place for food and medicinal crops. In section 3, we intended to primarily plant species that could begin remediating the soil, so that later goat forage can be planted there. Section 2 shares characteristics of the other two sections, being drier than section 1, but not as nutrient poor as section 3. There, we wanted to plant some food crops, some goat forage, some pollinator-friendly perennials, and some nitrogen fixers. Based on soil preferences, we determined which one or two sections of the slope was best for each species on our final list.
Our deliverables for this project consist of 4 final sketches. The first is an aerial view site assessment and analysis. This will outline what grew on the slope previously, as well as permanent structures that we will need to plan around. The next is the plane view, which is an aerial view of the planting design of the slope. This will highlight the canopy widths of each species planted and give insight into our design tactics based on the plant shade tolerances and other characteristics. The third is the west elevation view of the site. This will show the slope as if you were standing at the base looking directly at it. We will include tree species and their heights. The fourth will be similar to the west view, however, it will show a cross-section of the slope looking south. It will show the pitch of the slope and tree heights along each contour. The images on the right here are some sketches that an NR group did for a plot they were designing for John in the past. So the leftmost image is a plane view of the site. It highlights canopy width, and there's species descriptions at the bottom. And then the topmost image on the right is just a general elevation view of the site, and you can see it highlights tree height and also canopy and shade cover. So we're hoping that our deliverables look something like this. There were several complications that arose while we were working on our project. In the first part of the semester, our ability to sample soil and contour the slope was largely dependent on the weather. Poor driving conditions, large amounts of snow, and frozen soil were persistent barriers. We were able to contour 2/3 of the slope before spring break. However, due to the global pandemic, we were unable to make any other site visits after spring break. This meant we were unable to collect soil samples. Fortunately, John already had a pretty good understanding of the soil on his farm and how it changes on that slope particularly. We were also unable to finish contouring the slope, so we focused on the bottom 2/3 that we had completed before spring break. While not being able to make site visits did make our project more challenging, we were still able to video chat with John, and he was able to communicate important information to us that way, including design skills. He also distributed drawing supplies like a base map, tracing paper, and rulers to our apartments in Burlington. Unfortunately, we will not be involved in the actual planting of the slope this spring. Despite all of the challenges, we look forward to finishing our deliverables, and we cherish the time we spent working with John and Wild Roots Farm. Thank you.